Hey everyone, welcome back to our course in trigonometry. Dr. Tom McNamara here. In this video we are going to discuss proving identities. So I've got a little review here for us. A couple of our basic identities to remember. We talked about this type of thing. We talked about proving identities a little bit earlier on. We're just going to do some more detail here. So these guys are known as the reciprocal identities. Cosecant is the reciprocal of sine, secant is the reciprocal of cosine. These down here we got the so-called ratio identities. Tangent theta is the ratio sine over cosine. Okay. So these are useful here. Another useful identity is the so-called Pythagorean identity. Cosine squared theta plus sine squared theta equals 1. And of course, if that's true, that implies several other things. And we'll need to be able to use all of them as needed. So, 3 different versions of this Pythagorean identity down over here. Okay, if we take this and get cosine isolated on the left, well, we would do that by subtracting sine squared from both sides. So, if we ever see 1 minus sine squared theta, we can replace it with cosine squared theta if that helps. And vice versa. If we ever see this, we can replace it with that if needed. All right, and we've got those others as well. And just some general advice. When we're proving identities, what we want to do is we want to start with the more complicated side So start with the more complicated side. Write everything using sine and cosine. Okay, so start with the more complicated side. Rewrite all the expressions using only sine and cosine. In other words, if you see secant in there, replace it. Instead of writing secant, do 1 over cosine. Once you've got these things done, then we're going to use some algebra. Okay, so cancel anything that appears both in the numerator and denominator. If you got a factor that appears both in the top and bottom, cancel it out. If you've got some parentheses, maybe you distribute to get rid of the parentheses. You might need to do some factoring. We'll see an example or two of that right here in a little bit. Okay, so let's go ahead and work some examples of proving identities. Okay, so let's try this. We are going to prove, okay, here's my textbook. I want to take an example out of our book. Okay. Going to chapter 5, section 1. We are going to prove that tangent theta over secant theta is equal to sine theta. All right, so let's follow that general advice we had. We're going to start with the more complicated side, which is the left side. Okay, now, don't do this. Do not write sine theta right here. Okay, this is supposed to be the last thing we write. I'm supposed to show, with my work here, I'm supposed to show how to turn this into sine theta. So we cannot write sine theta right now. We follow our general advice. Write everything using sine and cosine. So instead of tan theta, sine theta over cosine theta. instead of secant theta, 1 over cosine theta. All right, well, where can I go with this? I'm supposed to take this fraction, divide by this one. How do we do that? Well, multiply by the reciprocal, right? So sine theta over cosine theta times cosine theta over 1. Cosines cancel each other out, and we are left with sine theta. Okay, so start with the more complicated side, write everything in terms of sine and cosine, do some algebra, and get to the other side. Okay, another example. Let's try this one. Okay, so I want to prove that cotangent x plus 1 is equal to cosine x times cosecant x plus secant x. All right, so looking at these two options, this is where I'm going to start. This side is more complicated than the left side. I got 3 trig functions here. Over here there's only 1. So I'm going to start with that expression. Cosine x, cosecant x plus secant x there in the parentheses. All right. Well, what is that equal to? What can I do with these? Well, I'm going to replace each of these terms with expressions that involve exclusively sine and cosine. I look at my cosecant, I say, okay, that's the reciprocal of sine. So I replace cosecant with an expression that involves sine. I replace secant with an expression that involves cosine. All right, now I've seen, okay, I got this and an expression in parentheses. That means I should distribute cosine to each of the terms inside. All right, so over here, well, cosine over sine, go back to your ratio identity, that's cotangent. So we can cotangent. Cosine over cosine, well, that's 1. And look what we have here, it's what the other side is. Okay, so the idea with these identities is we are supposed to show how we can turn the expression on one side into the expression on the other side. This rewrite step here is critical. So I want you to start with the more complicated side, write that down. The next thing I want to see is that rewrite. And then, once you've done that, now work on your algebra. Okay, let's do an example where we bring in one of the Pythagorean identities. Those were the ones involving the square, the squares. Okay, so let's try this one. Okay, we're going to prove 1 minus cosine theta is equal to sine squared theta over 1 plus cosine theta. Okay, so in this example, looks like once again the right-hand side is the more complicated side, so that's where I'm going to start. Sine squared theta over 1 plus cosine theta. Now, I look at this and I see, well, everything is already in terms of sine and cosine, so I'm not going to make any progress there. But I'm looking at my Pythagorean identities. Sine squared. Is there anything I can replace sine squared theta with? And if you look back to the review that we did at the very beginning of this video, said I could replace sine squared with this expression if I wanted to. So let me try that. So my numerator can be replaced by 1 minus cosine squared theta. All right, now, so these are kind of just things I'm thinking about as I'm working this problem. Another thing I'm thinking about is this idea here. If you remember from your algebra, there's a way to factor the difference of two squares. A squared minus b squared factors into a plus b times a minus b. Well, this is a square. 1 squared is 1. So that's a square. That's a square. Let's apply the difference of two squares factoring to our numerator. So it says I should do 1 plus cosine theta, 1 minus cosine theta. Something squared minus something else squared. It factors into something plus something else, something minus something else. So here the something is the 1, the something else is the cosine. 1 plus cosine, 1 minus cosine. My denominator, don't forget about that, that's still hanging around over there. Okay, notice I've got a factor of 1 minus cosine theta in my numerator. I've got a factor of 1 minus cosine theta in my denominator. So all I'm left with is 1 plus cosine theta. Whoop. Sorry. That would have worked if the idea still works, I just copied it down wrong. This was a plus, so that should have been a plus. Okay, I knew I went wrong when I looked over here and I saw 1 minus cosine theta. I knew that was trouble. Now, so I've still got the factoring. I had copied down that wrong. I put a minus there. It's supposed to be a plus. Okay. Now that it's correct, we see that's the factor that cancels, leaving me with 1 minus cosine theta, which is what we were supposed to have right there. Okay, so modulo that little mistake. Let's look at the basic principle. I bring in the Pythagorean identity. Whenever I see sine squared, I can replace it with 1 minus cosine squared. Now you might say, well, how does that help? It helps because we can factor 1 minus cosine squared. And you might say, well, how do I know I should factor this? I'm looking at this. I'm seeing the right-hand side has a fraction. There's a denominator down here. There's no denominator over here. So right away that's telling me I got to look for a way to cancel out the denominator on this right-hand side. How do you cancel out the denominator? Well, you got to find a factor common with the numerator. How do you find a factor that's common with the numerator? Well, you got to factor the numerator. How can we factor it if it's just sine squared? That's why we bring this in. Okay, so it's a good example of using that Pythagorean identity to bring in a factor that can cancel out the denominator and get you to the other side. Okay, so remember, we're starting here because it's more complicated. We're doing our rewrites, we're doing our algebra, and then the last thing we do is reach the other side. Okay, you know when to stop when you hit that.